Hello dear friends. Welcome to this new video, where we will learn how a motor controller or motor driver L298 and a motor shield work. In robotics and automation projects, these parts are essential for controlling DC motors. We will talk about how they work, how to connect them, and how to program them using Arduino. We will provide examples and programs for that. DC motors are an important part of many electrical projects. They convert electrical energy into mechanical movement, making them useful in everything from simple toys to robots. When connecting DC motors to electrical power, they rotate in a certain direction. When this connection or polarity is reversed, the motor rotates in the opposite direction. To do this automatically, we need these controllers or motor drivers. An HBridge is an electrical circuit that allows the direction of the motor rotation to be changed. It looks like an H, hence the name HBridge. This circuit consists of 4 switches for the electrical current. By controlling these switches, we can change the direction of the motor rotation. We have the first possibility, or the forward direction, when switches S1 and S4 are closed and switches S3 and S2 are open. The current flows from the power source through the motor, making it rotate in the first direction. Then we have the reverse direction, when switches S2 and S3 are closed and switches S1 and S4 are open. The current flows in the opposite direction through the motor, making it rotate in the opposite direction. In addition to controlling the direction of the motor rotation, we can control its speed. This is the voltage applied to the motor. This voltage can be applied continuously, giving the maximum speed, or it can send pulses of a specified width, causing the motor to rotate at a lower speed. In this example, we have the motor rotating at maximum speed with 5 volts applied completely. In this case, when the voltage is changed to 0 volts, the motor stops. Then another case, the motor rotates slowly, sending pulses with a very short width, or the motor rotates at a moderate speed where the pulse width is somewhat longer than this, and thus the motor speed can be changed. After I finish setting up to test the motors using the motor driver L298N, I will now start programming the control board corresponding to the Arduino Uno board. The program is as follows. First, I gave names to the Arduino pins to match the pins of the motor driver. For example, pin 9 is IN1, the pin responsible for moving the motor first in the forward direction. Then pin 8 is IN2, the pin responsible for moving the motor in the reverse direction. Then pin 7 is IN3, responsible for moving the second motor in the forward direction, and pin 6 is IN4, responsible for moving the second motor in the reverse direction. Then I have ENA, which is pin 10, and through it a PWM wave will be given to control the speed of the first motor. Then pin 5 is ENB, the pin through which the PWM wave is given to control the speed of the second motor. Then we have the setup function where we will define all these pins to be outputs. Then we will initialize them with an initial value of 0 volts. Then in the loop function, which repeats continuously, we will move the motors in the first direction or forward direction. As you can see, to do this, we will set IN1 to 5 volts and IN2 to 0 volts, then IN3 to 5 volts and IN4 to 0 volts. Then we will set the full speed, 255 for both motors, and wait for 2 seconds to apply this at the motor level. Then we will stop the motors by setting all the pins IN1 to IN4 to 0 volts. Then we will wait another 2 seconds. Then we will reverse the direction by reversing this setup, and the motors will rotate in the opposite direction. Then we will stop, and we will go back from here. I will now load this loading the program onto the board. Now, I will change the speed so we can see the PWM control of the motor speed. I will set it to 64 here. As you can see, due to friction, the motor on the right struggles to rotate. So I will try with 128. As you can see, in the reverse direction the speed remains higher because it's set to 255, while in the forward direction it's 128. In this second setup, I used an Arduino shield, which is a shield placed directly on the Arduino board, saving a lot of wiring. As you can see, the program is as follows. First, I defined pins 12 dir A and 13 dir B, then pin 3 PWM_A, and then pin 11 PWM_B. Pins 3 and 11 are the pins responsible for speed, and pins 12 and 13 are the pins that control the direction of rotation of the motors, the right and left motors. In the setup function, we defined all these pins as outputs. Then in the loop function, we will set 5 volts to both dir A and dir B, which means moving both motors in the same direction at full speed 255. Then wait for 2 seconds, then stop the motors by setting PWM_A and PWM_B to 0, and then wait for 1 second. Then do the same thing in reverse so that the motors rotate in the opposite direction. Then the program will restart from line 13. Now, I will load this program onto the board. I will try reducing the rotation speed. As you can see, at a speed of 64, the rotation becomes slower. I added these lines, which reverse the rotation of each motor. Now I have finished the third setup, where I used the L298N HARD SHD. This shield is placed on the Arduino Uno. The program is also as follows. I needed this Adafruit motor shield library. After I installed this library, I defined 2 objects, motor 1 and motor 2, to be the motors connected to the shield. Then in the setup function, I set the speed for these objects or motors. The speed ranges from 0 to 255 as we saw with PWM. Then I made these motors move forward, then stop them, and then move them backward. As you can see in this case, the program was simplified, and this is due to using the Adafruit library. Now, I will load the program onto the control board. As you can see, we have covered the main motor drivers that can be used with the Arduino board. And so, we reached the end of today's video. I hope you enjoyed and benefited from it. Don't forget to like the video and subscribe to the channel to stay updated with all the new content. Until next time, stay creative and explorative.